Right, question number 9. A 2 kilogram block is pushed against a light spring of the force constant 400 Newton per meter, compressing it to 0.22 meter. So when the block is released, it moves along a frictionless horizontal surface and then up a frictionless inclined plane with slope 37 degree. So calculate the speed of the block as it slides along the horizontal surface after it leaves the spring, and then the distance traveled by the block up the inclined plane before it slides back down. Alright, so I know the question is lengthy, whatever. Okay, so I know the questions is quite long, but the steps is actually quite simple. So I've drawn the situation or the diagram. So this is question 9, right? So what do we have? We have the mass, which is equal to 2 kilogram, the spring constant, which is 400 Newton per meter, and then the delta x, which is the amount of compression, equal to 0.22 meter, and then the angle is 37 degree. Okay, all right, so now what we are actually going to use the conservation of energy. We know that energy is always conserved, right? So the first question, energy initial will be equal to energy final. Okay, so we have K initial plus U initial equal to K final plus U final. Okay, but what you have to know is initially the energy at the initial is for the horizontal spring. Horizontal sliding. Okay, this is for the horizontal sliding, whereas this energy here is on the compression of spring. Okay, so don't use mgh because we are now looking at the spring lah. Okay, all right, so now we know that there is no change in height for this horizontal sliding here, so automatically this one will be equal to 0. Okay, 0. Lepas tu, what else? When the spring is compressed, so when it stays at this position, the velocity will equal to 0. Okay, so at this point dia pun equal to 0 lah. Okay, so we are now left with only the kinetic energy of the block and the potential energy of the spring. Okay. All right, so half mv square, I'm just gonna use v sebab final tu tayo usahakan, so equal to the potential energy of spring, which is equal to half kx square. Okay, so the half here can be cancelled, so we are now left with mv square equal to kx square. We are looking for the speed, so this is just kx square over m square root there. Okay, so that is the equation. So just substitute. K is 400, x is 0.22 square over mass, which is 2 kilogram. So the speed you should get is equal to 3.11 meter per second. Okay, boleh. So this is just the usage of conservation of energy lah untuk solve the question. Right, so for question B pun sama juga. It's just that there will be a change in the gravitational potential energy lah, sebab dia mention about the inclined plane lah. The other change in height. Alright? Okay, so let's do that. Energy. Okay, so this one is when it is at the top. Okay, so when it is at the top, let me just try and draw the situation. So this is the inclined plane. Let's assume this is the block. Ugly. Okay, so the block is now at the top. So there is actually a change in gravitational potential energy due to the change in height. Okay, so this is this is H. Okay, there's a change in height. Okay, but what we are looking for is the distance traveled by the block up the inclined plane, which is this distance lah, which is the length of the inclined plane, gitulah. Okay, yes, kenapa ba tu? Right, so this is what we are looking for, L, the value of L. Boleh ya? I'm just gonna put it here. So for this one, we are gonna look at the top punya lah. So kinetic energy at the top plus dengan the potential energy at the top equal to kinetic energy of the spring plus dengan potential energy of the spring. Okay? So again, for the kinetic energy of the spring, when it reaches the inclined plane, up the inclined plane, the kinetic energy for the spring is 0. This is 0. And then the kinetic energy for the block at the top is equal to 0 as well, sebab it is resting before it starts sliding back down. Okay? Alright. So we are now left with mgh equal to half kx squared. Okay? Okay, so the value of h here is actually equal to L sine theta. So how did I reach to h equal to L sine theta? Is by using trigonometry. So this is our theta. We know that sine theta is equal to opposite, which is h, over the hypotenuse, which is L. So if we rearrange this, we'll then get h to be equal to L sine theta. Okay, so we can now substitute this equation into here. So mg L sine theta equal to half kx squared. So L is basically just kx squared over 2mg sine theta. Okay, so you should get the value of the distance traveled up the inclined plane to be equal to 0.82 meter. Okay, so that is the solution for question number 9. If you are confused about this energy equation, yang energy ni, we have to actually consider for the block and then for the spring as well. Okay, so but this is only valid for frictionless. Okay, so frictionless only. If the other friction, you have the other formula, which is, I think it's this one. So if it's not frictionless, you have to do the one yang ini. Okay, yang the one that I'm doing is frictionless, so that's why we can directly equate macam ni lah. Okay, alright, so that is the solution for question number 9.